Hello.
Does that sound any better?
Yeah, you got some background noise, but it was fine. Martin, what test did you do?
Can you hear me okay?
Yeah, not bad.
Cool. Yeah, basically, I thought the flat earth was a joke, like most people set out to troll people in flat earth groups, as you do. Um, and I tried to do a curvature test. I failed quite a few times doing it, because you can't do it over land for a start because of hills and valleys and topography maps and stuff. It's very awkward to do stuff over that. So the next object was to do it over water. Now, I'm quite lucky I live near the coast in North Devon in UK, and there's a beach called Westward Ho, and there's an island called Lundy Island. You can Google all this and have a look if you like. But it's 20 miles away. Now, 20 miles away, I should just about see the top third of that island. But I've got a P900. I've zoomed. I do
You
have one.
don't have a P900. That you
Right.
have to have.
Look
You
at
have to
my
have one
ring
to.
now and go
No,
on
I'm
to my. I have a TikTok account.
relax
All my. Yeah, well, why you got to be like that?
because it's the standard flat Earth bingo that you've all
Yeah, I
got a
get that, but
P900.
it's a good camera.
It
Yeah,
actually isn't. It uses the same size sensor as your phone.
Josh in the chat here is a professional photographer, so I think like he would know.
Well, fair enough, but it's still not telling me where I can see a lighthouse that shouldn't be seen at
What
20.
makes you think that it shouldn't be seen?
Well, because it's not high enough according to the Earth's curve. It should be
And
below the
how did
horizon.
you how did you figure that out?
Like I said, I had a lot of smart people helping
Are
me do
you
the
are you
test, and
using
all
8
of the
inches per
different
mile
maps.
squared?
I even went to the island. I've got topography maps of the island
Hmm.
to find out
Sure.
how high this
How
lighthouse
high
was.
how high was the lighthouse above sea level?
I believe it was about 50 to 60 meters high.
Okay. And how high were you above sea level?
I was at zero. I waited till the tide went out, and then I walked along the beach until I hit zero altitude.
Zero altitude. Well, how tall are you?
I'm 6 foot.
Okay,
Um,
so you weren't at zero.
no, I wasn't, but my camera was on a tripod.
Your camera was sitting on the ground, but
It
even then
wasn't
it's not
right
at
on the
zero
ground. It
because the
was
camera
probably
has a height.
about a foot, if that.
Did you did you cut out?
No, no, no. It was about a foot off the ground when I took the photo.
About a foot off the ground, and you're seeing a an object that's 50 meters above sea level. But then, how tall is the lighthouse?
The lighthouse, I think, is 16 meters off the top of my head. Again, this is all on my TikTok page. You can
So
go and have a look.
so a
All
hundred and the
the
top of the
videos are on
lighthouse
there.
is 110 meters high above sea level.
Sorry, what?
The top of the lighthouse would be 110 meters above sea level.
No, it's not. The
Well,
rock it's
if
on is only 50 meters. The lighthouse itself is only 16 meters tall.
16 or 60?
1 6.
1 6. Okay. So 66 meters. And what was the refraction index that day?
Off the top of my head, I couldn't tell you. It was
Did you
probably
take
about
that into account?
2018 I'd done this test. It was ages
Okay.
ago.
Did you take that into account?
I went there and done the test on several different days. Some days I couldn't see the island, some days I could
Mm.
see it clear as anything.
So if the Earth is flat, why can't you see it every day?
Because you don't have limited vision, you have perspective vision. That's why train track lines tend to join in the middle when you know full well they don't.
Hmm. Yeah. See, the thing is, all of these long distance observations, we can predict what you should be able to see if we take everything into account, including the Earth's curve. I'm assuming what you did is used 8 inches per mile square to figure out the drop from the tangent and said, oh, we shouldn't be able to see it. But that's not how you do that. It's just using the math incorrectly.
But there's plenty of websites that show you how to do the curvature things.
To be
Yeah, and
fair,
none of
to be
those
fair,
go ahead.
sorry, to be fair to Martin, he's done more work than most flat earthers with this. Like, at least he's bothered
Sure.
doing some kind of maths.
Thank you, right? But also, I didn't do it to prove to anyone else the Earth was flat. Again, I went out to make flat earthers look an idiot.
Did you ever make an observation to show that the horizon isn't at eye level, as it would have to be on the ocean if the ocean was flat? The higher you go, the more the horizon rises to eye level if the ocean is flat. But in reality, the higher
Well,
you
no,
go, the
I
more it
can't
dips
get
away
much
from
higher
you.
than 6 foot. So,
Well, yeah, but even at 6 feet, you can show that it dips away from horizontal. It's actually even easier to show that than your observation. And if
Martin,
the
Martin, do you have any other evidence other than this observation that you made? Is that what you're basing your beliefs on?
well, yeah, because it didn't work. And not only that, other videos I've seen of other people that do flat Earth curvature tests, they all seem to do the same thing. I'm not saying the Earth's 100% flat. It could be a globe. It could be a lot bigger than we're told.
No, we know exactly the size. I mean,
How
we
do
can
you?
just travel around it.
Australia is that big?
Yeah, but you don't know what's past Antarctica.
Sure, we do. We've circumnavigated Antarctica many, many times. There's a yacht race that circumnavigates Antarctica. They leave from France, go to Antarctica, sail around Antarctica, come back.
You get to go and see
There's
the
been
tourist bit, but you don't get to see the bit that Admiral
But
Byrd
that's
went.
no, no,
but that's
no,
not
no.
what he just said, Martin. He's just said to you there's an actual race that does do that, that circumnavigates the entire Antarctica and back to France.
Yeah,
Yeah, but
they
they're
they
going
come
around.
at it from the north. They head south, go around it, and come back north. Like Antarctica is always on their right or always on their left, depending on which direction they're circumnavigating. It's always
Yeah, it'd
always
be
in the
the same
middle of
if
where
the
they're
Earth
going.
was flat and that was the what they call the ice wall.
Yeah, but it'd be much
But there
bigger then,
isn't
wouldn't
as
it?
well.
They'd be turning away from it all the time and it'd be much bigger, but instead I'm assuming they're turning towards it all the time and it's much smaller.
But how would they know they're going straight across water if they're rowing?
They're not rowing, they're using boats and navigating.
Or well,
It's not a
yeah,
rowboat race, it's a sailboat race.
yeah. But how do they know they're sailing straight?
Well, they use things like GPS today. In the past, you'd use something like a sextant. Also, those
You
only
wouldn't
work on
use
a
a
globe.
compass then.
Yeah, you can use a compass, which also only works on a globe.
Well, it doesn't because if you're at the equator, north would be pointing upward.
Yeah, and if you're at the equator with a compass, it points north.
Whereas if you're on a flat Earth and you're on the equator, it'd be pointing sideways to the North Pole.
What? I don't think you understand how a compass works, perhaps.
Sideways.
Well, yeah, because if you're on a globe and you're holding a compass, it'd be pointing upward, not to the North Pole. It'd have to be pointing to the floor.
Well, compasses don't point towards the North Pole. Compasses follow the magnetic field that's above us. It's not literally pointing towards the North Pole, it's just following the magnetic field. You can do so. What you can do is buy a handheld compass, get a bar magnet and some iron shavings, put the bar magnet flat on the table, sprinkle the iron shavings around. It's going to show you the magnetic field, and then you can move the compass outside of that magnet where the iron filings are, and you're going to see that the compass needle follows those iron filings. It's just following the magnetic field. It's not literally pointed to the North Pole or to the South Pole. And it would be the magnetic pole, not the actual geographic North Pole.
Martin,
Hello?
do you disagree with that?
Well, no, I know how magnetic forces work.
What about an obvious one? Star rotations in the sky.
What, that they rotate the different way that in southern hemisphere than north hemisphere?
Yeah, hemisphere.
And have a center of rotation for both.
Yeah.
I don't know about that. I'm not an astrophysicist or whatever you want to call it.
You don't need to be an astrophysicist to see it.
But I can't see it. I'm in the north, so I would never see the south. I can never witness it for myself. I have to go on second-hand knowledge, not saying that other people are lying.
Well, you could if you traveled there. I mean, it's not
Yeah.
that hard. Sure, it costs money, but it's as simple as jumping on a plane and looking up once you get there.
Yeah. Again, like I say, I don't know too much about it. I haven't really looked that deep into it. All I'd done was what I was able to do, what I was physically able to do myself.
Fair enough, but what would be an explanation for that, though? The fact that if you're in the north and you look towards the pole, like towards north, you see the sky rotating around a point going anti-clockwise. Then you go to the southern hemisphere, look towards the pole, and you see the sky rotating around a point clockwise. Like, that is an observational fact. If it was the sky that was rotating above us, is that what you believe?
No, not necessarily.
But the sky rotates, right?
Well, no, because it's a solid firmament. It doesn't.
So you don't think the stars move?
The stars move.
Right, so what's rotating then?
Well, celestial bodies. As to what they actually are, no one knows. You don't know exactly what the sun or the moon are.
Doesn't matter what they are. They're moving, right? So is it the firmament that's moving, or is it us that's moving?
It's the bits in between that are moving. The firmament's solid, the floor's solid.
So how can it rotate in two different points then?
I have no idea.
Does that not make you disprove the flat?
No, not really.
Why not?
Well, how do I not know that the stars I see from the North Pole rotating in one direction is one set of stars, and there aren't more sets of stars down south that rotate in tangent, so you would think that it was one separate star system.
Is your firmament like an upside down bowl on top of a table?
I mean, generally that's
Mine is.
I wouldn't say a dome as such, but it's normally how lids work.
Oh, Erin.
Suppose you.
How would that give us if that bowl has a bunch of holes in it that create the stars, let's say, and we shine a light through the holes to create the stars, and then we rotate that bowl.
The bowl would have to move because that's what's projected.
Yeah. Totally agree. So we rotate that bowl, and we have a little camera inside. How do we get two different center of rotations depending on where that camera is placed inside? Do you see what I'm saying? Like, if you have a dot in the very top of the bowl, sure, there's a center of rotation if you're looking at that. But how do you get a center of rotation if you're looking south? You never would.
Yeah, I can kind of see what you're saying.
Or a really easy way to do it is get an office chair like this one, pick a point in the ceiling and spin whichever way you want, doesn't matter. Concentrate on it, then look at which way the ceiling appears to be spinning in relation to you. The ceiling obviously isn't spinning, you are, but the way it appears to be spinning. Keep spinning the same way, don't stop, then look down, and the floor will appear to be spinning a different way to the way that the ceiling was spinning. So
Yeah, because you've just changed your visual point of angle.
Yeah, exactly. So that can only happen on a three-dimensional object, a globe, a flat plane. You couldn't get 2 points doing that unless at some point in the sky you could visibly see the stars going in different directions.
And that's the main point. In order for flat Earth to be true, it has to be able to explain the simple observations we make in reality. And as we're showing you, the star rotation doesn't make sense on the flat Earth.
It only doesn't make sense because we don't know the answer to it.
Why wouldn't we be able to know the answer to it? Humanity has been on the Earth for a pretty darn long time. We're pretty smart creatures.
But you don't know the answer to everything. No one does.
Martin,
what's the meaning of life then? This should be a good one.
Martin, quickly, Martin,
don't know the answer to these things.
Martin, quickly, right? So all I'm going to say is, you will say to that, but we don't know the answer. So that could be anything, without really thinking about it. You just know that doesn't work for you, so you don't want to accept that it's reality. But let me ask you this: when you do your observation, what you was talking about earlier on, and then Josh says refraction, there's an explanation for why you can see different buildings at different heights on different days. It's provable that refraction exists, but you don't accept that as a reason as to why you're making that observation.
No, I'm happy to have refraction.
Yeah, but you didn't account for it when you was calculating what you should see, and you have to account for it.
But what was the refraction that day? How much refraction?
Well, that's for you to find out. You was the one. You should have looked at the conditions on that day and put them into your sums that you was doing.
But they were put
it. Huh?
They were put into it.
They weren't, because you can't even tell us. So you didn't do them then, are you saying? Someone else did it.
Someone else done the information for me.
And they accounted for refraction.
Yeah. And they still couldn't give me an answer as to why I could see what I could see.
I'm going to say that isn't the case. Because if we account for all these things, we can predict what you should be able to see.
Again, like I say, I don't have all the information to hand. You're more than welcome to have a look on my TikTok page, my Facebook page. You just got to scroll back a good 6-7 years. Good luck to you.
How do you falsify the measurements of curvature that we can make?
What do you mean, how do I falsify it?
So we make measurements of curvature, and they're pretty darn accurate. To the point where planes will use the curvature in calculating their flight paths and how far they're going to have to fly and so on and so forth, because flying over a curve, if you take a curved path, it's further than if you just fly straight. So we make those measurements. They always work out. They're extremely accurate. If the Earth is flat, then those measurements have to be false.
I don't get what you're going on about.
We have geodetic surveyors who take measurements and find out how much the Earth is curving.
So the Earth isn't 8 inches per square mile, or 7.9.
It's a fine approximation over specified distances, but eventually that isn't going to work, because 8 inches per mile squared.
Yeah, so let's say anything within 100 miles isn't going to become one of those, I can't remember the name of the shape, looks like an egg. I can't remember the technical name for it.
Parabola,
Nah, I mean
Yeah.
mine's gone
oblate
blank.
spheroid.
Nah, that's Neil deGrasse Tyson's word, isn't it?
Well, it's the actual shape of Earth. It's oblate.
Yeah, no, the name of the angle that it is it? Oh.
An oval? What? I don't know.
No,
I don't
it's
know what
kind
you're
of an
trying to say.
oval, but it goes out. I want to say
Parabola. It's a
an
parabola
or
you're
something
talking about.
like that.
That's the approximation. That's the 8 inches per mile squared is a parabola.
Yeah, but you can say it's okay for say 100 miles at least.
Yeah.
Right, so like I said, my test was within 20 miles, so then it should definitely work. It's over water, other than the odd wave getting in the way, covering the shoreline.
And refraction.
Again, yeah, and you
It,
say
but
refraction.
but what you're doing is taking the drop height and
Hold on
saying,
a second, Lewis. I'm going to bring someone else up here. Hold on. Keep going.
yeah, what you're doing is taking the drop height and saying, hey, it should be hidden behind this much drop, and the lighthouse is this tall, so I shouldn't see it. That is the incorrect way of doing it, because that drop height is from a tangent, and you're not looking directly horizontal out at that tangent.
I don't think it's gas. Someone's saying this is gas pressure. This is not gas, is it? This person.
No, I don't believe so.
Lewis, what was your question?
Hi, mate. Thank you for having me up. Martin, buddy, obviously assuming that you're an average income kind of guy and you don't struggle for money here in the UK, I would honestly advise you to go. You can go onto a website called Kmont. Oh, maybe that's an American one. I can't remember. I have a website for each country. You can spend around £40 on a meteorological weather balloon that can go up to around. This one I'm looking at is 70 to 85,000 feet, I believe. It's around 50,000 feet where you can properly see the curvature of the Earth. This will take a payload of about 1 to 2 pounds. So you can attach a cheap phone to it, make sure it's protected, put a GPS device on it. All in all, it can cost you maybe £1 to 200 at the very max. Send it up, go and find it, and recover the footage. I have asked people this before. I'm not saying this is what you would say, but somebody else did say to me like, "Oh no, like my phone would be hacked and they would like alter the images and the data or anything like that." But I would recommend, if you're so passionate about this topic, to go and do that, because I'd love to see the footage too. It's very
Yeah,
cheap to
yeah, I'm
do.
willing to give that a go.
Yeah. Um, yeah, the website that I found is called Kmont. I think they deliver to the UK, but I'm sure there's another website in the UK where you can buy like a meteorological balloon. But yeah, GPS device, cheap phone. Go to one of the second-hand places that sell like a cheap little phone. Set it all up, put it on record. Make sure you've got enough space on the phone, and you've got to go recover the weather balloon. That can be the difficult part. But that's why you can put like a cheap little GPS tracker on it as well.
Yeah, this may be a problem because if I get a high wind and that goes out towards the ocean, I ain't definitely getting that back.
But there's obviously, again, like obviously there is a chance that you might not get the weather balloon back. What some people also do, I've seen somebody else do this experiment. You can make sure that the phone has credit on it, and you can set up a cloud system. So as soon as the phone lands anywhere, it will just upload the footage to the cloud, and then you don't actually have to go and recover it too, which is a very easy and simple thing to do, depending on how tech savvy you are. You know what I mean?
Yeah, yeah. What about if I was to go live when I send the balloon up on this not phone? So if I get it back, it's not a
You'd
problem.
you'd lose signal after a few thousand feet,
What? So
unfortunately.
getting closer to a satellite, I'd lose signal. How does that work?
Well, actually, a lot of the satellites, the GPS would be fine. It's the phone signal that they're not like UK phone signals are not powered by satellite. They're powered by different. I don't know the correct name, but like towers basically. That's how the network in the UK works when it comes to phone signal.
5G towers, yeah.
It's
That's why
it's the
when you
way it
if
works in the
you've
US as well.
yeah, if you've ever been on a plane, Martin, you'll know that you don't have a phone signal up on a plane because the signals just can't reach up that high.
Yeah, yeah.
But Actually, a fun fact for anyone else: if you're ever on a plane and your phone's in flight mode, if you just turn it off, it won't do anything. You can actually sometimes pick up a GPS signal, and you can actually see like where you are in the GPS because the GPS is separate to the phone signal on a lot of phones. I've done this before multiple times. I'm flying next week. I'll probably do it again.
Would you be prepared to do that, Martin?
Yeah. But obviously, I'm a single father of 3 children. I'm not making up excuses, but I have responsibilities. I can't just go chucking money out here, there, and everywhere. But I will have a go at. I will have a. You say it was K Mount, yeah?
Yeah, I look at K-Mont. It's Kaymont. I think they have shipping to the UK, but I'm sure there must be a UK one as well because I've seen some that go up to like they cost like £1,000, but you can get pretty cheap ones that cost less than £50, and they hold like a payload of up to like £2, so it's more than enough for like a small little GPS phone and a protective case for the phone or something like that. Obviously, I wouldn't be able to provide you exactly what you need, but if you just did a little bit of research, you'll find out what you need. And if you ever, decide that you've got enough money to pay for it, I would encourage you to do it. You need one that goes above
like I say, when I did
50,000
the
feet.
curvature test, I had to go out on boat journeys to the island. Use topography apps on my phone just to double check that these what I was reading was right about the lighthouse being certain heights and stuff like that, and rocks that were certain heights and stuff. So I'm all up for giving it a good go.
My good friend Kakage in the comments has just had a good idea, like a GoFundMe. Like if you're part of a community of people who are interested in this, you could potentially do like a GoFundMe perhaps and see if you can get it crowdfunded, get together a couple of £100 and see what happens.
Where's that? Have we got a flat Earth millionaire? That's what his name is, isn't it? Flat Earth millionaire keeps offering to do things, but never actually does any of them.
Honestly,
yeah, it's funny that, isn't it? The ones with money don't want to spend it, yet me broke as fuck is willing to give it a go. Sorry,
Well,
I
that's a credit. That's
yeah.
a credit to you, Martin, because you're actually interested to find out the truth rather than just interested in being right. And that's what a lot of people do.
Like I say, a lot of it was a joke to start with. Do you know what I mean? But then obviously when I saw what I saw, I can't deny it.
Yeah, I've come across like 2 types of people who enjoy the flat Earth stuff, and there's one which is like people are happy to talk about and happy to be even proven wrong or listen, and then you've got another group of people. I think I briefly mentioned them earlier. I offered this same idea to them, and they were convinced that if they did this, that their phone would be hacked and the footage would be doctored.
That's
and
just an excuse to get out. Your phone ain't being hacked, and we don't have CIA pigeons on the phone lines. And
I do have
some of it is a bit too far fetched, but yeah.
I do have another follow-up question though that I posed to a flat earther actually this morning, because a lot of people obviously get caught up in the science, like and all this type of stuff and all these fancy words and sciencey stuff. I don't understand it. Like I wouldn't pretend to. But where my approach comes from is like, and this is the thing that most people can't. 98% of the world can't really talk on this topic with authority. It's that tiny 2% who can. But what I would say is, when it comes to any like conspiracy, right? We can talk about the science all day, or some people say that they can. What about like the motive and the other type of evidence, right? Like I'm sure you've had this argument before, Martin, about like what it would take for like this conspiracy to be true.
I get that, and I do get that, and ideally, yes, there would be a lot of people in on it, or there's just that many people now that take the globe for what it is when they're first born. They don't really look into it. It just is what it is. I mean, let's face it, you think Santa's real until you're old enough to figure him out he wasn't. But I think a lot of it's to do with control and the prices that we pay on things. Let's say there is more land out past Antarctica that's rich in coal, oil, gold, diamonds.
How could there be though? So this is a problem. One of the main problems I have with flat Earth is that you're now saying about land beyond, which I've heard before, but you're also saying about a firmament which is on the ice wall. You think the firmament is there, right? Starts at the ice wall. You'd have to be that to get your crazy light patterns.
I never said the firmament starts at the ice wall. The ice
Right,
wall.
so how would the light work
How
on a flat
far
Earth
how
then?
far the ice actually goes could be anyone's guess. This firmament could reach over another 300,000 or 400,000 miles. I don't know. We can't
So,
get past Antarctica. So
but then the dome wouldn't work, would it, with the light patterns?
what do you mean?
Like the dome, the firmament that flat earthers talk about when they bend all the light around to make sure it's got daylight on the ice wall for the entire outside of the map for 24 hours, would need a dome to make that light bend
The
around.
site,
That's the model they use.
yeah, that's the model they use.
But there's no other way of doing that.
Well, no, the sun and moon move around the stars would be on a flat roof moving around. It'd practically be flat to us.
Right?
I think
As to how high it goes, who knows?
The
if I
height is
can,
irrelevant. Go on, you go ahead, Lewis.
I was just going to say, I just wanted to very quickly. Oh,
Do you
Martin, if
know
you want to
who Martin
respond.
Kenny is?
No.
What's his name? Sancho. I think his name's Sancho or something, right along them lines. But
Who?
Martin Kenny does a version called the Cosmic Egg, which it's basically, it looks like a wedding cake, but not quite height differences.
I know what you mean, yeah.
And there's different rings with different lands. He thinks that Mars and Venus are the sun and moon going round the next plane around the Earth, and then you've got Saturn and Jupiter, which are the sun and the moon going round the third ring. I think he calls it the Bhumandala, which is, I think, one of the Indians' religions version of it, ancient versions of it.
So they wouldn't get any light from our sun and moon, and we don't get any light.
No, well, they'd have different light coming from Saturn or Jupiter, whichever one's classed as the sun over there.
So you think that Jupiter is self-lit?
Possibly.
Do you think the moon is self-lit?
Yeah.
How? Hello, Cleo. So how is there ever shadows on it?
Who said they're shadows?
An
How do you know
eclipse?
those black spots aren't where the moon's breaking down?
What about an eclipse?
I believe that there are, well, I believe there are more heavenly bodies up there that aren't just the sun and the moon.
All right. So the extra heavenly bodies are casting a shadow on the moon.
Well, a lot of people call it the black sun. People call it Rahu Ketu. I believe NASA call it the north and south nodes. There's something else up there.
Well, NASA say there's an extra celestial body that we don't know
No, they
about.
call it a north and a south node, and that's where they say that the moon and the sun cross each other's path, which is what causes the eclipses.
But what is the eclipse? It's a shadow on the moon, right? Whatever's causing it.
Yeah.
So that if it was
So
self-lit,
here's one for you then, right? If one object's moving in front of the light source and it causes a shadow and it goes quite dark during an eclipse, yeah?
yeah.
Then why when a cloud that you cannot see the sun at all covers the sun, we still get light? And I'm not just talking about a little cloud, I'm talking full overcast, the sky is grey, you cannot see nothing. It's still light. Don't
The
go as
sun,
dark as the
the sun isn't a torch shining down onto one point. It's lighting up all of the particles around the sky, all around it, everywhere.
Yeah,
From every direction, it's a sphere.
yeah.
So that's why. Because it isn't a torch.
But if a moon caused a shadow, then makes it go pitch black. Surely a cloud would do it that's closer to us.
It doesn't go pitch black. What are you talking about? I've never experienced a pitch black eclipse.
It goes, well, I wouldn't say pitch black as in night, but it goes dark. I can't remember when the last one was. I think it was
The moon
around,
goes across. If the moon goes across the sun, the path of the sun, to cause the darkest you could get, right?
In the UK, I think it was about 97, 98. We had
I know what you're talking about. So say for that instance, the most extreme instance, it didn't go dark, but it went very like dusk-like, right? Because the moon was going across the path. But that is a solid object in front of the sun, not a fluffy cloud.
It doesn't make any difference what the object
Of course it
is.
does.
No, it doesn't.
Well, so if I shut my curtains versus put some smoke in the way, that would affect the light differently in this room.
If the smoke was thick enough, yeah.
Thick enough to be solid.
Yeah. Right, I've got to go and sort one of my kids out. I'll send you a follow.
Mate. Okay, mate.
And yeah, I will get back to you regarding that balloon thing. And
Cheers.
yeah, K-Mount, wasn't it?
Who?
K-Mount.
Came on?
Oh, he's on about the meteorological balloons. Yeah, K-Mont, K-A-Y-M-O-N-T. If not, I'm sure just Google meteorological balloon purchase and someone will sell them in the UK. You need to be above 50,000 feet.
50,000.
Above 50,000, yeah.
All right then. I'll keep you updated.
And no fisheye lens.
Yeah.
Yeah. No, I won't do a wide angle lens.
Right. Okay. Cheers for joining.
Yeah. Take care.